You are joining with the 2019 Inorganic Structured Essay question. Here, X is an S block element in the periodic table. The first, second, and third ionization energies are 738, 1450, which are small differences in values. And then finally, you have 7733, which means that's a big value. So, first electron, second electron, and the third electron has a large value. That means this gap tells that this element is a group 2 element, right? This element is a group 2 element. X reacts slowly. X reacts slowly with hot water, liberating hydrogen gas and forming its hydroxide. The hydroxide is basic. X also liberates H2 on the reaction with dilute acids and burns in air with a bright white light. You know what is this now? Cation of X contributes to hardness of water. So this cation is magnesium 2 plus, and X is going to be magnesium because X is an S block element. So you have to write magnesium, not magnesium 2 plus. So you have to be careful with that, right? So cation of X contributes to hardness of water. Now, where do you see this point? You see this point in industrial chemistry and environmental chemistry section. There you have water quality parameters, and then under that we discuss hardness of water. Under that you have this point. But since you have not done that, it's still you can still do this question from other points they have given. Hydroxide is basic, liberates hydrogen on heating with dilute acid, and then reacts slowly with hot water. These points you can identify the element without any problem. Electronic configuration you can write. I won't write that. Easy. Write the chemical formula of the two compounds formed when X burns in air. So when X burns in air, air contains mostly oxygen and nitrogen. Don't write the hydrogen compound. So it'll form magnesium oxide and Mg3N2. Consider the given compounds of the elements in a group in the periodic table which belongs to X and write whether the indicated property increases or decreases down the group. So group 2 we have to compare. Solubility of sulfates. Now, barium sulfate is insoluble in water, you know that. So, barium sulfate is insoluble and magnesium sulfate is soluble. So, this insoluble, soluble. So, down the group, the solubility will decrease, right? Then, solubility of hydroxides. Hydroxide is the other way around. Magnesium hydroxide is insoluble. I gave you this in the note, actually, water solubility note. Magnesium hydroxide solubility is very less, and when going down the group, solubility increases. So, you can write increase. And thermal stability of carbonates. You have to compare that polarizing power, polarizability, and then ionic character, and then thermal decomposition temperature. So down the group, what happens is polarizing power will decrease and ionic character increases. So thermal stability will increase. Give reasons for your answer 3. So here, these are the words you have to write exactly, right? So when group 2 compounds are all magnesium 2 plus, calcium 2 plus, strontium 2 plus, and then barium 2 plus. So these are the group 2 cations, right? So all of them have the same charge. So you have to write charge same. That's it. Simple English. Charge same. Cation radius, charge same, cation radius increase down the group. Cation radius increase down the group. Polarizing power decrease down the group. Therefore, ionic character increase down the group. Therefore, thermal stability increase down the group. That's it. Simple English. You just have to write the point there. It's not like biology. It's chemistry. So you have to write the exact point like that. Okay, fifth one, identify the element in the S block of the periodic table which reacts in similar manner to X. Okay, that's lithium, which show diagonal relationship with magnesium. That's lithium. Identify another metal cation that contributes to hardness of water. That's calcium 2 plus. You will find this, as I told you, in environmental chemistry. Seventh one, identify the compound mostly used to remove hardness of water. So sodium carbonate is used. This point also you will learn in that section. So actually you need to know some industrial here. Only few little amount of industrial you need to know in order to answer this question. X is a component, well-known reagent used in organic chemistry. Give the name of this reagent. It's Grignard reagent. In Grignard reagent, you have X. Grignard reagent. Okay. Test tubes labeled A to E contain solutions sodium thiosulfate, sodium carbonate, KNO2, KBr, and Na2S. Hari? So they are going to solutions obtained at the gases evolved on addition of dilute HCl. So dilute HCl is added and gases are evolved, right? So when dilute HCl is added, the appearance of the solution is given, the gas evolved is given. So properties of the gas evolved and the appearance of the solution, right? So A is a colorless solution. A gives a colorless solution. B also gives a colorless solution. D gives a turbid solution. You have to look into this, right? So what is the component here which gives a turbidity when you add dilute acid? It's only sodium thiosulfate, right? Sodium thiosulfate gives you sulfur precipitate. It gives you sulfur precipitate and SO2. So these two components are formed. So D, we know exactly that is sodium thiosulfate, right? Na2S2O3, right? Then we can cut off sodium thiosulfate. And then, so there is other one, KNO2. Now KNO2, when you add dilute acid, what happens is NO2 is evolved, right? So brown color gas is evolved. So reddish brown pungent odor, reddish brown with a pungent odor. So there you go, that's KNO2. Easy, right? So sodium carbonate. So sodium carbonate will evolve carbon dioxide. So colorless, odorless gas is evolved. Colorless and odorless gas is evolved with a colorless solution. Perfectly correlates with the sodium carbonate. Right, then C. Colorless with a rotten egg odor. Rotten egg, you know what is that? Sodium sulfide will produce H2S, right? When you add sulfide, when you add HCl into sulfide, you will get H2S, which is a what do you call gas with a rotten egg smell. And then finally, the remaining one is KBr. Nothing will happen to that actual colorless solution and not evolved. Gases are not evolved. Write the balanced chemical equations for the reactions that take place in the test tube. Once you identify these things, that's the only inorganic part there. So writing reactions are basic knowledge. So you can continue that, right? I'll write it briefly without balancing. So sodium carbonate reacting with HCl, you will get sodium chloride plus carbon dioxide plus water. And in B, you will get KNO2 plus HCl. You will get KCl plus NO2 plus H2O. Right. Then, yeah, after KNO2 in C, you will have Na2S. Na2S plus HCl. You will get NaCl plus H2S. Then in D, you will get turbid solution is formed. So sodium thiosulfate, Na2S2O3 plus HCl. You will get NaCl plus sulfur plus SO2 plus H2O. So all of these things you will get. Now balancing is up to you. You have to take care of that. Write a chemical test to identify each of the gases evolved in A, C, and D. Right. So A is carbon dioxide. So you can write lime water test. Lime water turns milky. You can't just write it lime water turns milky. You have to explain it. They have got told observations are also required. So what is lime water? What is like calcium hydroxide? You're going to react bubble through calcium hydroxide, and then it's going to give you what you call a milky color solution. After that, you bubble excess and it becomes color. So you can write that test. I won't write everything. Right. Then C. In C can H2S, right? So H2S, you can react with something like KMnO4, or you can react it with acidified K2Cr2O7. So for example, I'll write KMnO4 reaction. Now in the note, I have given everything. So KMnO4 and H2S, they are going to react together to form sulfur and Mn2 plus, right? So first thing that will happen is decolorization, right? It will decolorize and it will form the sulfur precipitation. It will form the sulfur precipitation, which will give you a turbid solution, right? You can write the observation like, okay, the solution decolorizes and becomes turbid. So that's the observation. So reacting with acidified MnO4 minus KMnO4, actually, you will get that observation. So you can write that for C. There are other examples also. I won't go through them very deeply. You can check our note. There are note I have given you how to identify H2S and what are the methods. So any of that will be suitable here. In D, sodium thiosulfate, you will get SO2, right? So SO2, same reaction, MnO4 minus, if you react, what will happen is, instead of turbidity, only decolorization occurs. No turbidity will form. මෙතන turbidity හැදෙන්නේ නැහැ. There will be no turbidity formed. You have to remember that. There is no turbidity formed. So only purple color will go to colorless. That's the only observation here. So same thing I have to tell you. In the note, you have these things. So I will tell you one example here. You can write that. But in the marking scheme as well as in the note, you have these sections. So yeah, you can go and check out that. Okay. So with that, the 2019, 19, right? Yes, 2019 structured essay question of inorganic is done. So thank you for watching. We'll meet you with another question from the past papers.